Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the earlier videos, I have discussed what is a synchronous counter, what is an asynchronous counter. Then I have discussed what is the sequential counter, the ring counter, Johnson counter. I hope you have watched all those videos. If you have not watched those videos, I request you to go back and watch those videos and come back to this video for better understanding. In this video, I want to discuss about asynchronous counter. Can anyone tell me the difference between a synchronous counter and asynchronous counter? If you know the answer, please write it in the comment section. Now let me discuss what is a synchronous counter, then I will discuss what is an asynchronous counter, then I will discuss why it is an asynchronous counter also. Now if it is a synchronous counter, let's see that this is a counter, this is a 3-bit counter. Why I am saying it is a 3-bit counter? Because you have 3 flip-flops, am I right? If it is a n-bit counter, you will have n flip-flops. For each flip-flop you are giving the common clock, then we will call it as a synchronous counter. If you are giving a different clock or the output of one flip-flop is acting as a clock for another flip-flop, then we will call it as an asynchronous counter. Now if you look at it, the output Q0, which is a output of the flip-flop T, then which is acting as a clock for this flip-flop. Similarly, the output of this one is acting as a clock for this flip-flop. So I can say that it is an asynchronous counter. Now let me discuss about this counter. Now if you look at it, T0, T1 and T2 are given as 1, and for T0 we have given a clock, and for T1 and T2 Q0 is acting as a clock and Q1 is acting as a clock. Now if you look at it, it is a negative edge clock. From a positive edge we are going to the negative edge. So if you look at it, T0, it is a clock where T0 will be enabled. T0 is equal to 1 for all the clock cycles. Am I right or wrong? Is it clear? Are you able to understand it or not? Okay. T0 will be 1 for all the clocks because you are giving the common clock. And similarly, if T0 is equal to 1, then what will happen? We will discuss later. Coming to T1. T1 is a negative edge clock. Negative edge clock means whenever Q0 is 1 to 0, are you able to understand? If Q0 is 1, Q0 next is 0, then only it will be enabled, then T1 is equal to 1. Similarly, T2 will be 1 whenever Q1 is going from 1 to 0. Are you able to understand it or not? Means Q1 is 1 and its next state is 0, then T2 will be equal to 1. Okay, are you able to understand? Now for doing this one, what I will do is that I will take the present states of each flip-flop. What are the present states? Q2, Q1 and Q0. Okay, these are the present states of the flip-flop, and I want to compute its next state such as Q2n, Q1n and Q0n. Okay, I hope you are following it. These are the next states and these are the present states. Now if you look at it, if these are the present states, sorry for it, this will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. These are the 4 input combinations. Similarly, you will have another 4 input combinations such as 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. These are the 8 input combinations we have. Okay, are you able to understand? Now T0 is equal to 1 for every clock. If T0 is equal to 1, what will be the Q0's n? Means its next state. Is it clear? To know that one, you should know the characteristic table of the T flip-flop. What is the characteristic table of the T flip-flop? It consists of Q, T, Qn and Qn plus 1, where Qn is the present state, Qn plus 1 is the next state. Okay, if you have t and qn are the inputs, you will have the four combinations of the input. Am I right? Now if you look at the characteristic table of the t flip-flop, if t is equal to 0, qn plus 1 means its next state is equivalent to its present state. So you will get 0, 1. When t is equal to 1, next state is equal to complement of the present state. So you will get 1, 0. This is the characteristic table of the T flip-flop. Are you able to understand? Now, for every clock, T naught is equal to 1. If T naught is equal to 1, what will happen? Its next state is equal to complement of the present state. So, Q naught N is equal to Q naught complement. What is Q naught? 0, 1, meaning is that you will get 1, 0, 1, 0, 1, 0, 1, 0. So, for each state, I am finding its complement. Here 0 is there, I am keeping it as a 1. Here 1 is there, I am keeping 0, like that I am doing. Okay. Similarly, if you look at it, T1 is equal to 1 when Q naught is going from 1, 0. Now look at it. What is Q naught is going from 1, 0? Its present state is 1, its next state is 0. Look at such combinations. This is 0, 1, no. This is 1, 0, this is 1. 1, 0, this is another, 1, 0, this is another, this 1, 0, this is another. So, in these four cases, T1 is equal to 1. Then what will be its next state? Its next state will be equal to complement of it. Okay? Complement of it. Q1's N is equal to Q1's complement. Okay? Here you have a 0 because this state. Okay? You have 0 here, you will get 1. Here you have 1, you will get 0. Here you get 0, 1, 1, 0. In other states, the T1 value will be equal to 0, which is equal to next state is equivalent to present state. So, what is the present state? 0. Next state will be 0, 1. You will get 1, 0, 1. Are you able to understand? Similarly, T2 will be 1 whenever the Q1 is going to from 1 to 0. Meaning is that Q1's present state is 1, next state is 0. Look at such combinations. Let me erase these four so that you can understand them. Q1 is 1, its next state is 1. No, it should get 1, 0. 1, 0. Yeah, this one. Let me tick it here. Okay. 1, 0. This is 1. That time what will happen? Q2N is equal to Q2's complement. Will you agree with me or? Because that time only T2 will be 1. Okay. So, where are the two cases? Here. Here it will be complement. 0's complement will be 1. Here 1's complement you will get 0. In the remaining term, Q2N is equal to Q2 only, which is 0, 0, 0, 1, 1, 1. So, I got the present states and next state. Now what I will do? I will draw the transition diagram. Okay. Then we will understand what is this counter is able to do. Okay. Now if you look at it, when it is 0, 0, 0, it is going to 0, 0, 1. Let me convert them into decimal numbers so that you can easily understand. 0, 0, 0, what is the equivalent decimal number? 0. 0, 0, 1 is nothing but 1. So, from state 0, it is going to state 1. From state 1, it is going to state 2. Okay. From state 2, it is going to 0, 1, 1. What is it? 3. Okay. From 2, it is going to 3. From 3, it is going to 4. From 4, it is going to 5. From 5, 1, 0, 1 is 5, 1, 1, 0 is 6. From 5, it is going to 6. From 6, it is going to 7. From 7, it is going to 0. Are you able to understand it or not? Meaning is 0 means it is going to 0. Are you able to understand? So, this is an asynchronous counter and it is a ripple counter. What it is doing? From 0, it is going to 1. From 1, it is going to 2. From 2, in the next state, it is going to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. Now you tell me what is the mod for this one. 0, 1, 2, 3, 4, 5, 6, 7. Am I right? How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So it is a mod 8 counter. Mod 8 ripple counter, which is an asynchronous counter. I hope you have understood how I got the mod 8, because here you have 1, 2, 3, 4, 5, 6, 7, 8. After that again it is going to 0. So it is a mod 8 ripple counter. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.